Okay, so have you ever like wanted to generate an awesome image, with AI? You've got your phone, you pull it out, you're ready to go, and then, oh no, storage full.
Oh, yeah.
Happens all the time, right?
Yeah.
These AI models, they take up so much space.
Yeah, they can be real space hogs for sure.
But luckily for us, some really smart researchers found a way around this. And today, we're going to be looking at a paper all about that 1.58-bit FLUX.
What's fascinating here is they're using this technique called post-training quantization.
Post-training quantization?
Yeah, so basically they're shrinking the model.
Shrinking it?
Shrinking it without retraining it.
That sounds pretty wild.
It is.
How do they even do that? Is it like compressing a file, like zipping it up or something?
It's a bit more involved than that. Imagine you have a digital image, right, with millions of colors.
Yeah.
And you reduce it down to, say, just black, white, and gray.
Okay.
You're simplifying the image's information.
Right. So instead of millions of colors, just 3.
Yeah, and that's sort of what quantization does with the AI model.
Oh, I see.
So instead of using this wide range of values, it's restricted to a smaller set.
Okay, and in this case, just 3, you said. +1, 0, and -1.
Exactly.
Wow, and that doesn't, totally mess up the images.
Exactly. Well, that's what the researchers wanted to find out. So they tested it, right, on these standard benchmarks like GenEval and T2I Compbench.
Okay, and what happened?
The results were astounding, really.
Okay, so how much smaller did they actually get this model?
Well, they managed to shrink it by, get this, 7.7 times.
7.7 times smaller.
That's like taking an entire encyclopedia and fitting it onto, I don't know, a tiny flash drive.
Wow, that's impressive. But I have to ask, doesn't shrinking it that much, reduce the quality of the images?
Well, you would think so, right? But that's the incredible part.
Oh.
They were able to keep the quality almost the same.
Really?
They even included examples in the paper, like they generated an image of a cat made entirely of seawater walking through a library.
That sounds pretty cool.
It is. The detail is incredible, even the textures. And there's another one, a dragon. This time it's made of fire, and it's spiraling over a city.
Wow, so they're not just blurry messes or something.
No, not at all. The quality is amazing.
Okay, I'm convinced this is the real deal, but how does it actually work? In practice?
That's where things get even more interesting. So they had to develop this custom kernel.
Kernel.
Yeah, think of it like a...
like the core of the model.
More like a specialized translator.
Yeah.
So it lets the model use those simplified values, the +1, 0, -1.
Wow.
And it does it quickly and without using too much memory.
So they basically had to redesign the way the model processes information.
Pretty much.
That's amazing. And this kernel thing, is it good for all kinds of GPUs?
Well, it's especially good for the less powerful ones, the kind you'd find in, say, a phone or a tablet.
Oh, which?
Yeah, so not only is the model smaller, it can run smoothly on devices that couldn't handle the original model.
So we could be seeing AI image generation on our phones.
Exactly, making it accessible to everyone.
That's pretty incredible.
It is. It really opens up the possibilities.
But before we get ahead of ourselves, what are the downsides? There's got to be some.
Right? Of course. Nothing's perfect.
Right.
So while it's efficient in terms of storage and memory, the speed improvements could be better.
Oh, so it's not lightning fast.
Not quite. And there are also some issues with preserving details at high resolutions.
I see.
But these are just a few limitations. Overall, the potential here is huge.
Okay, so this is just the beginning then.
Yeah, exactly. There's this thing called activation quantization, which could lead to even more efficiency.
Activation quantization.
Yeah, it's a bit technical, but essentially.
All right, well, for now, let's stick with what they did with 1.58-bit FLUX.
Okay.
And dive a little deeper into how they actually made it work.
Sounds good. One of the things that makes this paper so interesting is they use self-supervision.
Self-supervision.
Yeah, so normally with quantization, you have to retrain the model with a ton of data.
Right, which takes forever.
Exactly, and it takes a lot of computing power.
So they found a way to skip that.
Yeah, they use the knowledge that's already in the FLUX model to guide the quantization.
It's like the model's learning from itself, in a way.
Exactly, it's using what it already knows about images and text.
Wow, so they're not giving it more data.
Right.
They're just kind of tapping into what's already there. That's pretty clever.
It is, but then the question is, how do you make sure the shrunk-down model still knows what to create?
Right, good point.
And that's where the calibration data set comes in.
What now?
It's like a set of text prompts carefully chosen to represent the kind of input the model's going to see.
So instead of showing it more pictures, they give it text descriptions.
Exactly. And in this case, they used prompts from the Party 1K dataset.
Okay.
And also from T2I Compbench.
Right. And these prompts, they basically act as a guide for the model.
I see. So even though it has a limited vocabulary, it can still understand what it's supposed to generate.
Exactly. It's like giving it a cheat sheet in a way.
I like that analogy. Okay, so they chose FLUX for this. Why FLUX specifically?
There are a couple of reasons. So first off, FLUX is open source.
Okay.
Which means they could see exactly how it works, the code, the architecture, all that.
Yeah, like having the blueprints for a building if you want to renovate.
Exactly. And secondly, FLUX is already really good at generating images.
Right.
So starting with a high quality model increases the chances that the shrunk down version will be high quality too.
Makes sense. Choose a good starting point.
Right. So it's both practical because it's open source and it's a high performing model.
And clearly it worked based on those images they generated.
Absolutely. But let's not forget about those custom kernels.
Oh, yeah, we got to talk about those. I'm still a bit fuzzy on how they actually help. So remember how we're using those super simplified values, +1 and 0, -1?
Yeah.
Most GPUs aren't designed to handle that kind of data efficiently.
I can imagine.
Yeah, it's like trying to, fit a square peg in a round hole.
Right, it just doesn't work.
Exactly. So the custom kernels, they act as a bridge between the GPU and the quantized data.
So they translate it in a way.
Yeah, you could say that. So the GPU can process it quickly and without using too much memory.
Oh, I see. So they're not just simplifying the model.
Right.
They're also making sure the hardware can actually handle it.
Exactly. And what's really cool is that these kernels, they work especially well with less powerful GPUs, like the ones in your phone.
Oh, wow.
So they saw big speed improvements on GPUs like the...
I don't know much about GPUs.
The NVIDIA L20 and A10.
Okay.
So it's like they're unlocking performance that wouldn't normally be possible.
Yeah, that's pretty incredible.
It is, and it shows how important it is to think about both the software, the model, and the hardware, the GPU.
It's like a team effort.
Yeah, exactly. So we're talking about AI image generation, not just on powerful computers, but on our phones, on everyday devices.
And that's the goal, right? Making it accessible to everyone.
Absolutely. So this 1.58-bit FLUX, it's not just about technical stuff. It's about making AI more democratic.
Yeah, that's a good point. But let's get real for a second.
Okay.
Why should our listener care about all of this?
Well, think about it. Imagine you're scrolling through, Instagram.
Yeah.
And you see this amazing AI-generated artwork.
Okay.
And you think, hey, I want to try that.
Right.
But then you realize, oh, my phone can't handle it.
Storage full again?
Exactly. But with 1.58-bit FLUX, you wouldn't have to worry about that. You could just create.
So it's about making creativity more accessible.
Exactly, no matter what kind of device you have.
And businesses could use this too, right?
But of course, especially small businesses, they could create marketing materials, product visualization.
That stuff